Greetings and salutations, welcome to TFI, where I'm covering a topic that I've not covered in a good couple of years, and the landscape's changing when it comes to this topic. The advice has shifted dramatically since the last time I talked about this. And apologies, my voice is going to deteriorate dramatically over the course of this video. It's just that time of year. So this is all to do with Xeons versus Core CPUs in your workstation. If you're watching this, you're curious about what the differences between the two of them, I would suspect, or you're just curious as to which one you should go for, because you're not quite sure what the advice is and what the differences are. And that's you come to the right place for that, mate. So back in the olden days, right, it was as simple as this. If you wanted the fastest PC possible for 3D CAD or 2D CAD or anything really that's Autodesk based or SolidWorks, you would go for a core CPU, something that ran at the highest clock frequency, because our 3D CAD applications tend to run on a single core and you want that core to go the fastest as possible, so you'd go for a Core i7 or something similar. But if you work in business and you're in an office, you tend to be given a Dell or an HP or a Lenovo workstation, and they typically come with Xeon processors in. And the thing about Xeons from days gone by is they were very slow. They ran at a slower clock frequency, but you get reliability, you get support with those workstations. So it was a trade-off. They were more expensive, but they were reliable, supported, but a bit slower, quite in some cases actually quite considerably slower than the core CPUs that you could put in your own PCs. So that was the advice, mate. That was pretty much it. Fast as possible, go with a core. Maybe do an overclock on it. But sucks to be you if you're lumbered with a Xeon. But things have changed quite a fair bit recently. In fact, we're at a point now, and I guess this is at the heart of the advice that I'm trying to portray here, is that right now we have complete parity between Xeons and cores. You can now get Xeon processors from Intel that run at the exact same clock frequency as the core CPUs. So you can still get that reliability, you still get that support, but you also get the exact same, or near as enough, damn it, to the same performance as the core CPUs. You just need to know which ones to go for and how to find them. So let's hop on over to Intel's ARC website. This is ark.intel.com, and we'll just take a look at how things used to be. This is why a lot of the advice was the way it was, and why it's also no longer valid. So hop on over to the core processors from let's say from around 2014. Back in 2014, we had the Core i7 4790K, which was the Devil's Canyon Haswell refresh CPU, and it ran at 4.4 gigahertz back in 2014. And you could overclock that if you got a good chip to 4.9 or even 5 gigahertz. I had that CPU and it ran this channel for about 3 or 4 years, and it was an absolute screamer of a CPU. 4.4 to 5 gigahertz back in 2014 if you went for a core CPU. Hopping on over though to the Xeons from 2014. And we'll just take a look at the stark contrast between the two of them. So we had E3 V3 Xeons back in 2014, and you were lucky to get a Xeon that hit 4.1 gigahertz. The rest of them, you're looking at sub 4, 3.9, 3.8 and below. And that was the best you got back in 2014. And again, I guess it depends whether on Dell's, HP's, Lenovo's. It depends whether they even put these in their workstations. I don't know. But there's a good chance you would be given a workstation with a Xeon at around 3.5 to 3.7 gigahertz back in 2014, and the same would apply to 15, 16, and 17. The Xeons were all inherently slower, and the core line just went faster and faster and faster. And here we are now in 2019/2020, and we've got core CPUs now. Of course, we've got the i9 range of core CPUs, and the i9 9900K now boosts up to 5 gigahertz out of the box at factory settings, with a base clock of 3.6 to 4 gigahertz. So blazing fast across 8 cores. Of course, I'm trying to ignore and avoid the AMD Ryzen line of CPUs because that's a completely different discussion altogether. I'm just keeping this purely to Xeons and cores, but the presence of Ryzen has caused Intel to increase their desktop core line to 8 cores. Okay, you can get a Core i9 to 5 gigahertz. What about Xeons? Well, that's the thing. Very recently, Intel have created complete parity between the Xeons and the Cores. You just need to know which one to look for. So hopping back on over to the Xeon category, if you go into the Xeon E processors and then arrange this by turbo frequency, we've now got two Xeon processors, the 2288G and 2278G, that both boost up to 5 gigahertz, exactly the same single core frequency as that i9. And the reason for that is they are the exact same CPU. So what Intel do, when an i9 comes off the production line, if it's good silicon, they'll rebrand it as a Xeon, enable some additional feature sets, and then push that out as a Xeon 2288 or a 78G. And then you can see there 5 gigahertz with 3.7 or 3.4 gigahertz base frequency. So slightly lower base frequency, but that's nothing to be overly concerned about, because when you're pushing your 3D CAD application to its limits, you're going to be hitting boost clock on a single core for the most part. So you're going to be utilizing that max turbo frequency. And then going down the line, you can see we've got some at 4. Anything with an M on the end, by the way, that's a laptop mobile processor. But you can see we've got 4.9 here, we've got a 4.8. Some have 6 cores, some have 8 cores. So when it comes to you choosing which Xeon you put in your workstation, of course it does depend on which Dell, HP and Lenovo are actually putting into their workstation configurators, but it's a trade-off. So if you're only using Inventor, you might find that 4 cores is perfectly enough for you. You can save a bit of money going for the 2274G. You're only getting 4 cores, but you're still getting that 4.9 gigahertz boost frequency. Or if you've got a bit more money and it's available to be picked, you can go to 6 or 8 cores. Perhaps you use CFD, ANSYS. You might use other simulation software that utilizes all those cores, and then you'll get that additional benefit of those cores and those other applications, but then also the 5 gigahertz 4.9 or 4.8 turbo frequency for Autodesk Inventor. But of course, it's not always as simple as that. If that was only the limit of the Xeons that were on offer, it would be as simple as that, but it's not. Of course, Intel have a stack of Xeons, far too many of them, and it becomes a bit of a minefield, and it's very confusing. For example, going back into the Xeon processor category and then the W processors, this is a bit of a weird sort of contradiction, because the Xeons, by definition, I guess, in the way they've always been marketed and placed, they've always been in workstations, but now we've got this Intel W for workstation processor line, which is very confusing, but there you go. But these ones here have similar turbo frequencies to the E line, so we're limited to 4.6, but you can go for more cores if you want to and if you've got a bit more money to spend. So for example here, the 2245 workstation processor boosts to 4.5 on across 8 cores. You can get an E processor with almost identical specs to that 8 cores, 4.5 gigahertz. So what's the difference between an E and a W? Well, it's all down to what's inside of the specification table. So going down to the maximum memory size supported, you'll find that the W workstation processors have a far greater maximum RAM limit. You'll find that they've got more memory bandwidth, they support more memory channels, so those additional statistics make the W processors more expensive, but doesn't necessarily mean that we can actually use these. Inventor's not really going to benefit that much from more memory channels or more memory bandwidth, and I struggle to find anyone who's going to need anywhere near a terabyte of RAM for Autodesk Inventor or any other 3D CAD application. If you've got a data set that needs that much RAM, you're going to be finding bottlenecks elsewhere in your workstation. So that's pretty much it, mate. The general rule of thumb, when you're looking for a workstation now, my advice would be, yes, go for a Xeon. You can get the same performance now out of a Xeon if you are limited to buying the likes of Dell, HP, and Lenovo. But as a general rule of thumb, 6 cores minimum. Go for a turbo frequency of at least 4.5 gigahertz. Try not to go below that because you don't need to. Make sure you've got hyperthreading enabled as well. There are some of the Xeons that have hyperthreading disabled. Now, without, again, going too much detail with this, hyperthreading back in the olden days was advised to be turned off for 3D CAD applications, but that was back when we only had 2 cores. That advice is now obsolete. So although Inventor, AutoCAD, all the other 3D CAD applications, they're not going to be faster or slower with hyperthreading on or off. It doesn't make any sense to buy a CPU without hyperthreading when hyperthreading can benefit you in other areas of your workflow across your working day. So make sure it's got 6 cores, hyperthreading, minimum 4.5 gigahertz turbo frequency, and probably 3.4 or 3.5 gigahertz as a base frequency. Keep those stats in mind. Choose a Xeon, and you'll be on to a winner, but try and go for the highest turbo frequency as you can. So if you can get a workstation, if you can find one with that Xeon 2288G, I think it was, this one here, yeah, 2288G. If you can find a workstation with that in, that is the fastest you'll get a workstation to run Autodesk Inventor at currently today. So that's what to go for. Just a quick note on what to avoid, and well, it's pretty simple to be honest, mate. Avoid the default option that the likes of Dell and HP will give you on their configurator. So I just basically went on over to Dell's website here, going into their precision workstation range, clicking on the 5820, which is the current workstation you'll buy today. Give that a click. If you were to accept it, worryingly a lot of people do, if you were to just accept the default configuration that they give you, it comes with the Intel Xeon W2102. That's what they give you as the default choice. And that CPU is woefully inadequate. Hopping on over to the ARC page for it, it has only 4 cores with only 4 threads, so no hyper-threading. Its maximum frequency is 2.9 gigahertz, which is dreadful. You will find you will be probably worse off with this workstation than what you have now. So if you were to just get that, you'll find yourself in a heap of trouble because that is woefully poor. So what you want to do is go into the, depending on what time you're doing this, which part of the year you're doing this, which website you're on, go into the configurator and then take a look at the statistics. So the 2125, 4 gigahertz, 4.5 boost, 4 cores, not a bad price. But you might want to go for more than 4 cores. If we hop into more, we've got the 2145. That is a good CPU. I've actually got this one at my desk at work. 4.5 gigahertz, 8 cores. But it's just a trade-off. The more money you put into it, the better the spec you're going to get. You might find that you don't need 8 cores. You might be fine with 6 cores, for example. So you can save 100 quid, but then you lose 2 cores. So yeah, it is a trade-off. But you can see here, Dell do not offer the 2288G. So you can either just be happy with this one here, and honestly, even though we know the 2288G is the best one that money can buy today, it's not going to be noticeably worse going for something like this. It's not like you're going to have a completely polarizing experience going for a 2145 or a 2155 instead of the 2288G, for example. So yeah, as a general rule of thumb as to what to avoid any and all of the Xeon CPUs which have a metal in their name. So that will be the scalable processors, Platinums, Intel Xeon Golds, Xeon Silvers, and Xeon Bronzes. Avoid all of those. They should not be in workstations. They are server data center CPUs. And I've got a feeling the only reason that these vendors are putting them in their workstations is because they're contractually obliged to shift a bunch of them. But they're woefully inadequate for what we do, and honestly, I don't think they're suitable for any workstation applications. So, right, I'm going to call it here, mate, because my voice is really struggling right now. It's breaking up and deteriorating. But hopefully that gave you a good idea as to where we are now with Xeons and Cores, and the fact that you can now get a Xeon that runs just as fast as a Core, as long as you can find it in a workstation. So yeah, I'll knock that on the head there, mate. Thank you very much. Yeah, I haven't even got it in me to plug any of the additional bits and pieces. I'm just going to knock that there, mate. Cheers. I'll see you in the next one. Doodle.